For decades, US power has rested on one promise: unmatched military strength. But what if I tell you that all this military power depends on one small country? Because American dominance isn't built on troop counts alone, it's built on technology. It rests on the ability to project military power anywhere on Earth, quickly, decisively, and with technological superiority no rival can easily match. This is what protects US security, stabilizes alliances, and keeps competitors from challenging the existing balance of power. And it all depends on one small thing: chips. Tiny pieces of silicon engineered at the scale of atoms embedded deep inside every advanced US weapon system. Without them, the hardware still exists, but it becomes useless. And this dependence doesn't stop with the military. The same advanced chips are now the foundation of the global AI race. They power the data centers training next-generation models. They drive the processors behind automation, intelligence analysis, and economic competitiveness. Whoever controls access to these chips controls the future. And here's the part most people don't realize. Almost all of those chips come from one place: an island smaller than many US states. An island sitting at the center of the most dangerous geopolitical fault line on Earth. An island whose factories quietly power not just smartphones and data centers, but the military and technological backbone of the United States. That island is Taiwan. And to understand why the future of global power now runs through it, we need to understand how one company quietly became the most important industrial actor of the 21st century. In the late 1980s, Taiwan made a decision that almost no one else thought was worth making. Instead of trying to design flashy consumer electronics or compete with American tech giants head-on, Taiwan focused on something far less glamorous: manufacturing other people's chips better than anyone else on Earth. That strategy produced TSMC. While companies in the United States and Europe obsessed over designing faster, smarter processors, TSMC committed itself to a single mission: becoming the most advanced semiconductor manufacturer in the world, without competing with its own customers. This mattered more than it sounds. Most chip companies face a built-in conflict. If you design and manufacture your own chips, your customers are also your competitors. TSMC removed that fear. It promised neutrality. Anyone could design the world's best chip, and TSMC would build it, no questions asked. Then Taiwan doubled down. For decades, the Taiwanese government treated semiconductor manufacturing as strategic infrastructure. Massive subsidies, world-class engineering education, power grids, water systems, and logistics networks designed specifically to serve chip fabs that operate non-stop year-round. What made this decisive was timing. Taiwan invested before advanced chip manufacturing became a global bottleneck. By the time other countries recognized semiconductors as a national security issue, Taiwan already possessed decades of accumulated expertise, supplier ecosystems, and process discipline. Advanced semiconductor manufacturing is not just about capital, it is about learning curves. Each new node introduces new physics problems, yield challenges, and failure modes that can only be solved through experience. These lessons compound over time. By the time the rest of the world realized how hard advanced chip manufacturing actually was, Taiwan was already years ahead. As of late 2025, TSMC produces over 90% of the world's most advanced chips below 7 nanometers, and roughly 70% of the global foundry market overall. These are not commodity components. They are the processors that enable AI systems, guide precision weapons, and secure military communications. And once you fall behind in semiconductor manufacturing, you don't catch up quickly. Which leads to the next problem. Because advanced chips are not just another industrial input, they are the foundation of modern power itself. In earlier eras, global power was measured in steel, oil, and industrial output. Today, it is measured in compute. Advanced semiconductors sit at the center of nearly every system that defines modern strength. Precision-guided weapons rely on chips that can process sensor data in real time. Secure military communications depend on encryption hardware that must be fast, compact, and energy efficient. Hypersonic systems require processors capable of operating under extreme heat, vibration, and speed. Even nuclear deterrence has changed. Modern nuclear modeling relies heavily on simulation rather than physical testing. These simulations require immense computational power, made possible only by the most advanced chips available. And then there is artificial intelligence. Training large AI models requires massive data centers filled with cutting-edge processors. Deploying AI systems at scale across logistics, intelligence analysis, and industrial automation depends on access to the same advanced semiconductor nodes. This is not optional. Without access to advanced chips, a military does not slowly weaken. It falls behind structurally. Systems become harder to upgrade, decision cycles lengthen, technological edges erode quietly, then suddenly. And this is where dependency becomes unavoidable, because the United States does not manufacture most of these chips itself. Companies like Nvidia, AMD, Apple, and Qualcomm design the most advanced processors on Earth. Architectures, software stacks, and accelerator designs remain largely American strengths. But design is only half the equation. Manufacturing advanced chips is brutally difficult. It requires machines costing hundreds of millions of dollars, supply chains spanning dozens of countries, and tolerances measured in atoms. At the center of this challenge is extreme ultraviolet lithography. These systems are among the most complex industrial machines ever built. Each unit requires years to install, tune, and integrate into production lines. This is why semiconductor manufacturing capacity cannot be rapidly expanded. Unlike traditional factories, chip fabs are constrained by physics, yield stability, and process maturity. Today, when an American company designs a cutting-edge chip, there is effectively only one place capable of producing it at scale: TSMC. This dependency runs deep into US national security. Numerous defense platforms, including aircraft systems, radar arrays, missile defense components, and intelligence infrastructure, depend on chips fabricated by TSMC. Even as the United States works to rebuild domestic capacity, progress is slow by necessity, not negligence. The CHIPS Act has funded new fabs on US soil, including TSMC facilities in Arizona. By 2025, these fabs are producing 4nm and limited 5nm chips, but the most advanced nodes, 3nm and beyond, remain concentrated in Taiwan. In other words, America designs the brain, Taiwan still builds the neurons. And that reality shapes global politics in ways most people never see. For decades, US dominance rested on the assumption that technological superiority could be sustained through innovation and diversified manufacturing. That assumption no longer holds. Today, a single geographic choke point underpins Western military power, AI ambitions, and economic productivity. This concentration introduces systemic fragility. It does not require catastrophe to matter. Even modest disruptions, delays, prioritization changes, regulatory constraints can cascade through defense procurement and industrial supply chains. Modern weapon systems operate on long upgrade cycles. Missed production windows translate into multi-year capability gaps. This is why Taiwan has become strategically irreplaceable. It is not only about economics, it is about time. If Taiwan's chip output were interrupted, not destroyed, not invaded, simply constrained, the effects would be immediate. Defense contractors would face shortages, AI development timelines would stretch, advanced weapons upgrades would be delayed because the silicon does not exist. This is where geopolitics quietly tightens its grip. US alliances, deterrence strategies, and military planning increasingly assume uninterrupted access to Taiwan's semiconductor output. Western influence, in practical terms, is now tied to the stability of Taiwan's factories. This dependency narrows options. It raises the cost of instability without a single shot being fired. Which brings us to a scenario few policymakers discuss openly, but all prepare for quietly. Imagine a future where Taiwan continues producing chips, but stops supplying the United States at scale. No invasion, no dramatic headlines, just prolonged export restrictions, regulatory shifts, or supply chain severance driven by political pressure. The effect would not be instant collapse. It would be worse. Military modernization programs would slow. Advanced platforms would rely longer on older hardware. Intelligence systems would face processing bottlenecks. AI deployment would become constrained by availability rather than ambition. On the civilian side, shortages would ripple through aerospace, telecommunications, energy, and advanced manufacturing. Costs would rise, production would stall, innovation would bottleneck at the factory floor. And critically, time would stop favoring the United States. Because while America expanded domestic manufacturing, a process measured in many years, strategic competitors would continue narrowing the gap, which leads to the final question. What happens if the gap closes? The United States does not need to fall behind everywhere. It only needs to lose ground where it matters most. Advanced competition rewards speed, integration, and compute density. Small differences in processing power can determine sensor reach, response times, and decision quality. AI development rewards scale and continuity. Disruptions do not pause progress evenly. They advantage actors with secure supply chains and sustained production. This is not about collapse. It is about balance. A world where advanced chips are no longer reliably accessible to the United States is a world where dominance becomes contested rather than assumed. Influence shifts quietly, from those who design the future to those who can physically build it. Taiwan did not become the most important place on Earth by accident. It mastered the one industry every modern system depends on, and did so thoroughly that replacement is not quick or easy. Today, the engines of US military power, AI leadership, and economic strength all trace back to the same source: uninterrupted access to advanced semiconductors. The future is not predetermined, but one reality is clear. In the 21st century, global power no longer rests only on weapons, money, or alliances. It rests on chips. And for now, the world's most important chips are made on a small island that almost no one talked about, until everything started depending on it. So what do you think? Let me know in the comments down below if you think that Taiwan is the most critical geopolitical flashpoint of our time. Thank you, and see you next time.